This is about simplifying interactions with WebAssembly using a type-safe scripting language called as REPL. So for the most part of the talk, it is going to look obvious. The slides will be self-explanatory, and that's the whole point. You're trying to make the interactions with WebAssembly look quite obvious to any developers. Obviously, I need to start with why WebAssembly. Some of you might have tried WebAssembly, some of you may not have, but most of the time I feel like this group in LambdaConf is always into the bleeding edge. So you might have seen this repetitive set of advantages of WebAssembly, that it is fast, it is portable, it is lightweight, it is secure, and it enables multiple programming languages to interact with each other, probably even without a network stack in between, and many, many advantages. But the one thing that I love about WebAssembly, when I learned WebAssembly for the very first time, which I never got a chance to talk about in any place, was its introspection capability. And I love everything about introspection, especially when I worked in functional programming languages where you write declarative programs that is optimizable, that you can see through, you can document it, you can do whatever things with it. Because of that control, it's so good to design a system using functional programming. But when we see that introspection capability in the big, a system-wide, using WebAssembly, it's quite satisfying. And what does that mean? Because I will decide, or I will see what you're trying to do with my system, and I will provide you the implementation on how to do it. And that's exactly we all do in functional programming, but in the small. But in WebAssembly, it's in the big. Now, because of that capability, for example, security is not after the fact. It's not a reactive security patches anymore. The platform team clearly has an idea what each of these applications are going to be doing in their system. And they can provide the implementation of that. And they can deny certain applications. Why do you want to use this interface for this particular use case? So it's clear and more precise, and you don't need to rely on a blanket security model thinking that everything is going to be secure. This is why many of the talks in WebAssembly during the initial days talks about avoiding supply chain attacks and so on. So this is what I love the most about WebAssembly. Obviously, I cannot go in detail about what is WebAssembly, how to do things, because this is more about interacting with WebAssembly, but yet I will go through 3 basic things that you need to know. And I want this talk to be useful for people who haven't never tried WebAssembly and yet onboard themselves. First thing, component. It's a unit of code. That's it. It's not the first thing that happened in Wasm, in WebAssembly space. It's evolved from the WebAssembly core module with more types coming into picture to interact with each other. But as of now, for those who are not familiar with this thing, it's a unit of code that you can run. VIT is a WebAssembly interface type, so we'll see some examples of this. It's a specification used to define how these components, these unit of code, should talk to each other in terms of types. Wasm time, one of the runtimes for WebAssembly, and it is a reference implementation of how all these things sticks together, like the component model, the WebAssembly interface types, and so on. And more than that, it's a runtime that we're going to be using. Okay, so now let's interact with WebAssembly components. Obviously, we need to build a component first, and then we need to invoke the functions in that Wasm component. One interesting aspect of this component model or WebAssembly component is that you can invoke the function while it is running. If you remember my last talk in LambdaConf, if anyone has attended, I was talking about invoking the functions in an ever-running workers, which is an instantiation of these components to understand the state of the computation of each of the things in the timeline streaming pipeline. And you can do that. But before I do anything with it, I need to test it, and that's what I'm going to be doing. I will be using Wasm time, CLI, to invoke the function in a Wasm component. And it is to be noted that as of today, or yesterday, the Wasm time dev release, only that has the capability for you to invoke functions in a component. Otherwise, it supports only invoking functions in a module for the stable releases. So we will build a component. We will see what is a WIT file, a quick skim through the component code base, and then try running it using Wasm time. So this is the WIT file that I was talking about. And the whole project can be called as a component. We haven't built the component Wasm, but this is a template. And you can create this project using cargo component new, and they call it as a command component. A command component works directly with Wasm time, CLI, that it has a run function in it. And then you can use either this command component directly to experiment things, but most probably what you may need is you have separate components built, and then you need to import it into command component and then re-export it and then use it using Wasm time. There might be other way of doing things as well. In this example, I have a WIT file within the command component. The only purpose of this WIT file is to showcase some examples of WIT types. You can see, this is a bidding API, and enum is, it reminds us of algebraic data types. It cannot take any arguments. Record, struct in Rust, case class in Scala. And then a set of functions that takes these as inputs and returns WIT outputs. So there are primitive types as well. There are other types such as result, option, tuple, and so on. So these are the set of functions. The only purpose of showcasing these functions is to how are we going to interact with these functions. And you can also see I'm intentionally importing something from outside, which is just demonstrating the fact that you can import a specification, import a component interface into the world of this component, and this component can export its API such that this component can be used in some other component and import it, and so on. So this also implies when you build this project using cargo component build, you create a Wasm, but then you have to compose it with the Wasm corresponding to that calculator interface, because that's when the implementations are linked. Until then, only the spec is linked. And otherwise, you'll get probably a runtime or compile time, or you can't build, I guess. I think you can't build it. And the way to compose is using a WAC, is a tool called as WAC. I'm not going to be demonstrating all that, but it's good to know. And now so assuming that I have built everything, because of time constraints, I have pre-built everything, and I'm going to be using Wasm time invoke. I'm going to pretend I'm doing it for the very first time, but it's all auto-completed. But this is auto-completed using history. And this is how you invoke a function using Wasm time, and that's about it. And this is not the most complicated example. This is a relatively simple example. Our WIT has got an add function in it. It takes a new item. A new item is a record, title, priority, deadline. So here I'm specifying the record in a syntax called as Wasm wave. So Wasm wave is a project that you can see in the Bytecode Alliance ecosystem that defines the syntax of the text encodings of this component model types. So title foo is a string, priority low, that's enum, deadline, an option of an integer. And it doesn't work, probably because the type is wrong. It doesn't say that. It's invalid value type at 49.50. And the reason for that is I know it because I have tried it several times. Deadline is an option of string, and now it works. It's pretty evident how limited it is. I'm not going to go and explain the disadvantages as a demo, but I will be explaining it as a slide. It gets difficult with complex types. It's limited interaction capability. How do I take the output of that component and pass it to the next component? What about other complex type? What if I have n number of arguments to it? There is something called as a resource in bit file, so that you need to first create the instance of the component and then the instance of the resource, and then you have to invoke the functions in that resource. And apparently every time they keep changing the syntax, because before I had to give this foo or add function doesn't work directly, but now it works. But anyway, it's complex. Now let's see the solution to this. And that's what RIP is. RIP is a type-safe scripting language. We have built a REPL on top of it. Now, after this, everything is going to look pretty obvious. But there was a bit of pain to make that happen. Let's see that in action. So in my fork of Wasm time, I hope this gets through the Wasm time code base. But as of now, it's in my fork. You have the REPL enabled, and you pass the component name. You can pass a list of component names. The released version right now for the REPL works with only one component in the context. So first thing is, I will create an instance of that component. So this is basically creating a module instance to call it. So the context has bidder composed Wasm, that's the instance. And then the functions are auto-completed. These are not text search, but actually looking up at the compiler of RIP, and then auto-completing the function name. Now then comes how do you fill up the arguments? Click a tab. And now it pre-fills the value for you and sticks onto the type, and it works. And now you might, sometimes I need to know, okay, this auto-completion is good, but what was low? So I can use type inspection. So low is an enum. Let's showcase another example, maybe process user, which has more enum types in it. So what is backlog? It's a backlog. Backlog is an enum, low. And then you can take the output of a component function and obviously pass it to the next function. I'm not going to go in detail about how to interact. You get the gist of it already. And you can see multiple arguments auto-filled there as well. And it's all type safe. If there is any compilation error, it tells you where exactly the compilation error is and the type mismatch at the path deadline of that record, and it expects a string and it passes an integer, not something was invalid at the line 49 to 50. So we saw this. Parser errors, you cannot return if there is a parser error. So you have to fix it in line. Compiler errors, we have seen an example of that one as well. This was the error without the REPL, which I showcased, which is the direct use of Wasm time invoke. Now it's unfair to compare one-to-one because the responsibility of Wasm time, this was something that I got from talking to my colleague David yesterday. The responsibility of Wasm time is not to build a CLI, but it's the responsibility of us to make things easier to interact with WebAssembly, and that's what we are doing here. So what we achieved is quick type-safe interactions with Wasm components, method call syntax. We will see more examples of why we needed method call syntax instead of directly calling functions. Now, one point to note that you can actually directly invoke the function without an instance, but I don't think I will keep it forever because it will become instantly inconsistent in future. And autocomplete all the way, not just function names, but arguments. And enums and variants and stuff. You can inspect the type of these values anytime. And you can also distinguish component functions, etc. properly. We'll come to that example later. And descriptive compilation errors. And it's quite easy to onboard. Why? Because whatever you have seen until now is something that you're quite used to. Yeah, you're trying to interact with a component, with a code, and you just spinned up a REPL, okay, and then you're writing the code by invoking the function that looks like almost the bare basic thing that any developer would do. So it's very easy to onboard, and it still stick on to the Wasm wave syntax for Wasm values. So consistent method called syntax. We have seen an example where instance was an instantiation of the component, and then there is something called as resource in bit file, and I'm creating an instance of that resource. So cart here is a resource, and now I can call the functions within that resource. So any hierarchy will be consistent with a method called syntax. And here is how you can distinguish components. If there are multiple components in the same context, you can distinguish it using type parameter, and the type parameter takes root package names. This is not yet released, but the next one is released. Distinguish functions within a component. So if there are ambiguity between functions within a component because same function name existed in multiple interfaces, the type parameter can take the interface name as an argument, and it works. And this is not tied to any Wasm time. This is an embeddable REPL. It's a library crate, and we will see another example of how REPL is used outside. And in fact, that's a place where it is originated from. So how about stateful applications? Well, we can somehow make it work through by having another persistence layer in the component, but I don't want to deal with any DB or running another HTTP. At that point, I would rather switch to something known as Golem OSS. We discussed it many times previously in the previous conferences. So at this point, honestly, this is the easiest way to build applications that are stateful instead of re-engineering things with Wasm time, because at that point you are redoing things what Golem team has done. I can write application with an in-memory map, and I don't need to use any DB. I don't need to re-engineer what Golem has done in running a component forever. So let's see how quick it is. I'm running out of time, but I will try and make it quick. So this is Golem server running. This is a similar component. I'm starting Golem REPL. It's a clean server, so I'm deploying it. And we have already seen some examples. So here I'm passing a name to that instance, which makes it a durable worker. It's going to be running forever, and the state will be persisted. And now, or maybe I can auto-complete it instead of searching the history. So I'm creating a resource, okay, and then let me add stuff, and resource.get cart contents, persisted, application is ready. So it's dead simple to bootstrap an app now as well. With the latest Golem app, it's just Golem app new, and you can just, it's an interactive shell, and you can follow the instructions and then directly start Golem REPL. If the component is not deployed, it will deploy on the fly. So we have seen that. So more on RIP syntax. This document covers most of it. It has the grammar, types, and other features such as if-else, pattern match, list comprehension, reduction, ranges, and many more. This is an example of a non-exhaustive pattern match. Quite revolutionary. Well, that's what I said. It's obvious, and we need to make obvious things work. This is if-else condition. Again, quite simple. This is invoking component function in a for loop, and that 1 to 10 is a range. So anyway, so that was a quick overview of the syntax, and I can't go into every syntax details of Golem in a 25-minute talk, but here is another use case where we use RIB in Golem. It's in the API gateway of Golem. So we have seen RIB in Wasm time now. We have seen RIB in the Golem CLI. We are also using RIB in a component called in a feature known as API gateway in Golem, which allows you to expose component functions as HTTP APIs, which implies you need to define an API definition, and it will be a set of routes, and each of those routes will have an embedded RIB in it, which talks about how to interact with the components. This is an example RIP script. You can see the first line, I'm saying request.path.user, where request was not defined anywhere else. So is that going to be a compile time error? Yes, by default, yes. If you're directly using Golem RIP compiler, request is an unknown thing. But you can customize or you can configure the compiler to accept certain valid global variables. And we will say request is a global variable. And then the compiler will infer the type of the request to be a record because it needs a path in it. And the path should be a record because it needs a user in it. And a user is a string because that's what you said. And then I'm creating an instance of the worker. And then I'm passing request.body to the user, which implies RIP will assume that request should have a body in it, and that body should stick on to the requirements of the add user function. So now you can see where this is going. You can automatically generate a spec from this RIP script if it is used in the API definitions. And we are getting there in generating the OpenAPI spec, but we have got all the ingredients to have a lossless OpenAPI spec from these API definitions. So it's another capability of RIP that I wanted to showcase. Now, I'm not going into the details of how it is implemented. This has got 15 plus compilation phases that are completely independent, of which some of them are important phases that runs for multiple times. It scans this code base or a script to and fro until it reaches a fixed point, where a fixed point of the inference is defined by the fact that you're trying to accumulate the types as much as possible, but more and more accumulation doesn't change the meaning anymore. And in fact, that's exactly how we are implementing it. This is actually a snippet from RIP implementation. We are running that function, scan and infer is actually the inference, and I'm running it forever until it reaches the fixed point. And it compiles down to an IR, and its own intermediate representation. It's a stack-based interpreter. And as I said, it's configurable compiler and interpreter. And we have already seen the examples of customization. For example, REPL is a customization of the interpreter in terms of it's an incremental interpreter compared to the other one. And immediate things to fix. Not everything is perfect, obviously. There are issues in GitHub, which I raised even yesterday. And there are standard functions and user-defined functions, not yet there. The precise and better compilation errors, it's not good yet, and we are trying to improve. There is already a PR for that. But the design of RIP and the way we are trying to achieve all of this is looking promising. So it's only going to get better. And you can find more details here. These are the links. Obviously, I'll be tweeting it, and I hope you enjoyed the talk. I don't know if there is time for questions, but I'll be always available outside.
Thank you very much, Afsal. Is there anyone who has a question here? Raise your hand. Just a sec. We're going to give you a microphone.
So I know nothing about WebAssembly. So one thing I noticed is that you just call instance with some default like constructor, and I assume that means that there's no way to pass some other component to another component. So it's all functional composition, I assume. In the REPL, for example, when you say let x equal instance,
yeah.
like you're assuming there's one component in that file, then you're instantiating it. But my question is more that how do you compose components in WebAssembly?
So component composition in WebAssembly is outside. So for example, you may have multiple components in the context of REPL, of which one component is already a composed component. Otherwise, it can't work. The REPL cannot invoke the function because that component was not built properly. So
so it's that build time, basically.
So yeah, you have to, before you load it to any environment, be it Wasm time or be it Golem REPL or whatever, you have to make sure that the components are composed. Otherwise, it won't work, because you're saying in component X, I'm importing component Y. And then, in order for you to successfully execute functions in component X, because X needs the implementations of Y, you have to first link the implementations. So first you have to compose the components and then load it to the REPL. But that said, in the REPL, you will have multiple components in the context.
Unique, distinct components, essentially.
Two distinct components.
Yeah.
And then they might have some relation to each other. and you can distinguish them as I mentioned in one of the slides.
Awesome. Thank you.
Thanks, Adam.
All right, do we have time for one more question? Anyone else? All right, well, let's have a nice round of applause for Afsal.
Thank you, everyone.